Good day, everyone. Our topic for today is Chapter 3 Scheme Appraisal for Highway Projects. Introduction. Once a transportation plan has been finalized and the demand along each of its highway links has been established, a process must be put in place that helps identify the best solution for each individual proposal within the highway network. Each project must therefore be subject to an appraisal. The aim of the highway appraisal process is therefore to determine the economic, societal, and environmental feasibility of the project or group of projects under examination. The process enables highway planners to decide whether a project is desirable in absolute terms and also provide a means of choosing between different competing project options, all of which have the ability to meet stated goals and objectives of the project sponsors. The reason choice model of individual or group decision provides a decision-making framework within which scheme appraisal can take place, providing a technical foundation for non-recurring decisions, such as assessment of a highway construction improvement proposal. Z 1992. It comprises the following steps. Problem recognition. The decision maker determines that a problem exists and thus a decision must be reflected on. Goal identification. The decision maker details the desired result or outcome of the process. Identification or of alternative highway schemes. Different potential solutions are assembled prior to their evaluation. Information search. The decision maker seeks to identify characteristics associated with an alternative solution. Assessment of information on alternative highway schemes. The information necessary for making a decision regarding the preferred option is gathered together and considered. Selection of preferred highway scheme. A preferred option is selected by the decision maker for implementation in the future. Evaluation. The decision is assessed a period of time after its implementation in order to evaluate it on the basis of its achieved result. Economic appraisals of highway schemes. At various points in the development of a highway project, the developer will require economic assessments of the route option under consideration. This will involve comparing their performance against a current situation, termed the do-nothing alternative and/or against the do-minimum alternative involving a low-cost upgrading of the existing facility. Computation are performed on the costs and the benefit associated with each highway option in order to obtain one or more measures for each. Engineering economics provides a number of techniques that result in numerical values termed measures of economic worth. This by definition considered a time value of money, an important concept in engineering economics that estimates the change in worth of an amount of money over a given period of time. Some common measures are worth I of worth are net present value, benefit cost ratio, internal rate of return, cost benefit analysis. Using this method, any proposal having a positive net present value is economically sustainable in absolute terms, where competing project options are being compared assuming they are being used in identical capacities over the same period. The one with the numerically larger NPV is selected. The main steps in the technique involve the listing of the main project options, the identification and discounting to their present value of all relevant costs, the benefit required to assess them, and the use of economic indicators to enable a decision to be reached regarding the proposal's relative or absolute desirability in economic terms. Identifying the main project options. This is a fundamental step in the CBA process where the decision makers compile a list of all relevant feasibility options that they wish to be assessed. It is usual to include a do nothing option within the analysis in order to gauge those evaluate against the baseline scenario where no work is carried out. The do minimum option offers a more realistic course of action where no highway is constructed but a set of traffic managed improvements are made to the existing route in order to improve the overall traffic performance. The term feasible refers to options that on a preliminary evaluation present themselves as viable courses of action that can't be brought to completion given the constraints imposed on the decision maker such as lack of time, information, and resources. There are many procedures for both identifying and defining project options. This includes drawing on the personal experience of the decision maker himself, as well as other experts in the highway engineering field, making comparisons between the current decision problem and ones previously solved in a successful manner, examining all relevant literature. Some form of group brainstorming session can be quite effective in bringing viable options to light. Brainstorming consists of the two main phases. 1. Within the first, a group of people put forward in a relaxed environment as many ideas as possible relevant to the problem being considered. The main rule for this phase is a member of the group should avoid being critical of their own ideas or those of others no matter how far-fetched. 2. The second phase requires the planning engineer to return to normal judgmental mode to select the best option from the total list, analyzing each for technological, environmental, and economic practicality. This is in effect a screening process which filters through the best option. One such method is to compare each new option with an existing tried and tested option used in a previous similar highway proposal means of a T-chart. This is the example of T-chart. Identifying all relevant costs and benefits. The application of cost benefits for project assessment in the highway area is made more complicated by the wide array of benefits associated with a given road initiative, more easier to translate into monetary values than others. Many of the benefits of improvements to transport projects equate to decrease in cost. The primary groupings that contains this type of economic gains is termed user benefits. Benefits of this project occur to those who will actively use the proposed installation. These groupings includes reduction in vehicle operating costs, saving in time, reduction in the frequency of accidents. This is the main group of impact considered within a standard highway (CBA). Other studies might address in some way a secondary groupings of benefits, those occurring to non-users of the proposed facility. These include positive or negative changes in the environment felt by those people situated either near the new route or the existing route from which the new one will divert traffic. This can be measured in terms of the changes in impacts such as air pollution, noise, or visual intrusions, obstructions. The loss of improvement of recreational facility used by local inhabitants, or the improvement of deterioration in access to these facilities. Reductions in vehicle operating costs. This constitutes the most direct potential benefit derived from a new or upgraded highway project. It is often the most important one and the one easiest to measure in money terms, while the users are initial beneficiaries of these potential reductions. Circumstances dictated by the government policies or computations, or the drive to maximize profits, might lead to other groups within the broader community having a share in the ultimate benefit. Saving in time. The upgrading of a highway installation will invariably reduce time travel as well as improving the reliability of transport service. For transport users, time has come time has some connection with money. The degree of correlation between the two depends primarily on manner in which the opportunities made possible by the increased availability of time is utilized. Reduction in the frequency of accidents. Assessing the economic benefit of accident reduction entails two steps. In the case of the highway, this requires comparison of accident rate on the existing unimprovement highway with that of other highways elsewhere in the country, constructed to the higher standards of the proposed new road. Normally, the higher the standards of construction of a highway, the lower its accident rate. The second step involves the monetary valuation of the accident reduction. Three, three types of damage should be considered: property damage, personal injuries arising from serious accidents, fatal accidents, economic life residual value, and the discount rate. The highway project is often complex and long-term, with the costs and benefits associated with it occurring over a long time frame, which we term the life of the project, a parameter dealt with the earlier chapters. It sets a limit on the period over which the costs and benefits are estimated, as all must occur within this time slot, be it 25, 35, or even 50 years or more. It is related in principles to the expected lifetime of the other project under analysis. Use of economic indicators to assess basic economic viability. Once the two parameters of project life and discount rate are set in place, these allow all costs and benefits to be directly compared at the same point in time. The decision maker must now choose the actual mechanism for comparing that and analyzing the costs and benefits in order to arrive at a final answer for the net benefit of each of the project options under consideration. Any of the three techniques listed earlier in the chapter can be used for this purpose. Net present value, internal rate of return, benefits cost ratio. An NPV will estimate the economic worth of the project in terms of present worth of total net benefits. The IRR will give for each options under consideration the rate at which the net present value for it equals zero, with the BC ratio based on the ratio of the present value of the benefits of the present value of the cost. For the last two methods, if the options under considerations are mutually exclusive, an incremental analysis must be carried out to establish the best performing one in economic terms.